The universe appears seamless. Stars move, atoms vibrate, light travels across billions of years, and time seems to flow without interruption. Yet buried beneath this appearance is a question so strange that modern physics still has no answer. What actually connects one moment to the next? Not what happened a second ago, not what will happen a second from now, but what exists in the gap between them. Every event in the universe seems to arrive from somewhere and continue into something else, but the bridge itself remains invisible. Some physicists suspect reality may not be moving continuously at all. It may be jumping through existence in ways we cannot perceive. If that is true, then the greatest mystery is not what the universe contains, it is what the universe might be skipping. There is an assumption so deeply woven into human experience that most people never realize they are making it. It operates silently beneath every memory, every expectation, every decision, and every observation. We rarely question it because it feels self-evident. The assumption is that time moves continuously. We believe that one moment naturally becomes the next. We believe there is an invisible bridge connecting every instant of existence. We believe reality flows forward without interruption. The strange thing is that although nearly every human being lives according to this assumption, very few people have ever stopped to ask how we know it is true. Think about your experience right now. As you listen to these words, you feel as though time is unfolding smoothly. The room around you appears stable. Your thoughts seem connected. Your awareness feels like a continuous stream. If you look at a clock, the seconds appear to progress one after another. Everything gives the impression of an uninterrupted flow. But notice something unusual. You never actually see the transition itself. You experience one moment, then you experience another. Yet the mechanism that carries reality from one instant into the next remains completely hidden. This is a subtle point, but it changes everything. Human beings are experts at observing events. We see objects move. We watch stars cross the sky. We measure the growth of plants. We observe galaxies rotating and particles colliding. Yet all of these observations focus on states of reality rather than the connection between states. We see what reality looks like at one moment and what it looks like at another. What we never directly observe is the bridge between them. We assume it exists because the universe appears continuous, but the continuity itself is something we infer rather than something we directly witness. Imagine flipping through the pages of a book. The story unfolds in a logical sequence. One page leads naturally to the next. Characters move through events. Causes produce consequences. As a reader, it feels as though the narrative flows continuously, yet the story exists as separate pages. The continuity is created by the relationship between them. Now imagine that instead of a book, reality itself was composed of separate states. What if existence only appears continuous because our minds assemble these states into a coherent experience? What if the smooth flow we experience is not a property of reality itself, but a property of perception? This possibility may sound strange, but history contains many examples of assumptions that felt obvious until deeper investigation revealed something unexpected. For centuries, people believed the Earth stood still while the sun moved across the sky. The evidence seemed undeniable because it matched direct experience. Yet the appearance turned out to be misleading. The Earth was moving all along. The lesson was not merely about astronomy, it was about the danger of assuming that reality must operate exactly as it appears. Time may present a similar challenge. The flow of moments feels obvious because it matches experience. Yet when physicists examine the deepest laws of nature, they encounter something surprising. The equations that describe reality often contain no obvious mechanism that explains how one moment becomes another. They describe relationships. They describe states, they describe probabilities and interactions. But the actual transition between moments remains remarkably difficult to identify. Consider a movie playing on a screen. To the audience, the motion appears perfectly smooth. Characters walk, vehicles move, and entire worlds come alive. Yet the film is composed of separate frames shown in rapid succession. The continuity exists in the viewer's experience. No individual frame contains motion. Motion emerges from the relationship between frames. This raises an unsettling question. How do we know the universe is not operating according to a deeper principle that creates the appearance of continuity without requiring continuous motion at the most fundamental level? The deeper we investigate reality, the more mysterious the assumption becomes. Quantum physics reveals a world that often behaves in discrete ways rather than smooth ones. Energy can appear in specific packets. Certain properties exist in distinct states. Information itself may possess limits that challenge traditional ideas of continuity. None of this proves that time is discrete, but it does suggest that nature may be far less smooth than everyday experience implies. The hidden assumption every human makes is not simply that time exists, it is that time connects itself. We assume the universe automatically carries reality forward. We assume there is a seamless passage from one instant to another. Yet this assumption contains a mystery hidden in plain sight. What actually performs the connection? What mechanism ensures that the universe continues? What carries existence from the current moment into the next one? The remarkable truth is that science still does not possess a complete answer. We have extraordinary theories describing how reality behaves. We can predict eclipses centuries in advance. We can measure events occurring inside atoms. We can detect ripples in spacetime traveling across the cosmos. Yet the simple question of what connects one moment to the next remains surprisingly open. The continuity is real. Perhaps reality genuinely flows, or perhaps continuity is an illusion generated by deeper processes hidden beneath perception. Whatever the answer may be, the first step toward understanding this mystery is recognizing the assumption itself. We have spent our entire lives believing that time naturally moves forward, but once that assumption is questioned, an entirely new mystery appears. Because if the universe is not simply flowing from one moment to the next, then what exactly is it doing? There is something remarkable about every event that has ever happened in the universe. No matter how carefully we observe it, no matter how advanced our instruments become, we never actually witness the transition itself. We see what exists before a change. We see what exists after a change. But the passage connecting the two remains strangely hidden. This may sound like a small distinction at first, yet it leads directly into one of the deepest mysteries in physics. The universe appears to reveal every stage of reality except the one thing we are most curious about: the actual bridge between one instant and the next. Imagine watching a sunrise. The darkness gradually gives way to light. The horizon brightens. Colors spread across the sky. It feels as though you are witnessing a continuous transformation. Yet if you examine what you are actually observing, you never see a separate entity called transition. You see one state of the sky and then another. Your mind connects them into a smooth process. The connection feels obvious because the changes occur gradually, but the mechanism that carries reality from one state to the next remains invisible. This pattern appears everywhere. A seed becomes a tree, a child becomes an adult, a star forms from a cloud of gas and eventually becomes something entirely different. Every transformation in nature appears to unfold through time. Yet the deeper we examine these changes, the more we discover that we are observing a sequence of states rather than the transition itself. We measure positions, we measure energy, we measure motion, but the actual passage from one moment of existence into another remains hidden behind the results. Consider a simple example. Imagine taking a photograph of a moving car every second. In the first image, the car is at one position. In the next image, it has moved farther down the road. In the third image, it has moved again. Looking at the photographs, you can easily infer motion, yet the images themselves contain no movement. They contain only separate states. The movement exists as a relationship between the images. The transition never appears inside any individual frame. It exists only as an assumption connecting them. Now consider something unsettling. What if our experience of reality operates in a similar way? What if the universe presents us with states but never reveals the process that connects them? What if the transition itself is hidden from observation, not because we lack better instruments, but because it occupies a level of reality we cannot directly access. The strange thing is that science often encounters this limitation. In physics, measurements reveal the conditions of a system at specific moments. We observe particles before interactions and after interactions. We calculate probabilities, we map trajectories, we build models capable of extraordinary accuracy. Yet when we ask what physically carries a system from one exact state into another, the answer becomes less clear. The equations successfully describe change, but they do not always explain the underlying nature of the transition itself. Quantum mechanics makes this mystery even more difficult. At the quantum level, reality often behaves in ways that challenge ordinary intuition. An electron may occupy one state and later appear in another. A quantum system may evolve according to mathematical rules that predict outcomes with astonishing precision. Yet the transition itself often resists simple visualization. Physicists can calculate what happens. Explaining what is actually occurring during the change remains far more complicated. This creates a fascinating situation. Humanity has become extraordinarily skilled at describing events. We can predict the motion of planets. We can model the evolution of stars. We can trace the history of the universe across billions of years. But describing events is not the same as witnessing the bridge between them. The universe gives us access to the pages of the story. It does not necessarily reveal how the pages are connected. Part of the difficulty may arise from the way human perception works. Our brains are designed to construct continuity. When we watch a sequence of images shown rapidly, we perceive motion. When we hear a series of sounds, we perceive melodies. When we experience a sequence of moments, we perceive temporal flow. The mind excels at transforming separate pieces of information into coherent experiences. This ability helps us navigate reality, but it may also conceal deeper questions. We naturally assume continuity because continuity is what consciousness presents to us. Think about a movie projected onto a screen. The audience experiences smooth action, emotional scenes, and continuous movement, yet the projector is displaying separate frames. The gap between frames remains unnoticed because perception fills it in automatically. The viewer never experiences the interruption. The illusion of continuity is complete. This raises a provocative possibility. Could something similar be happening with reality itself? Could the universe be presenting existence in a way that naturally conceals whatever lies between moments? The mystery becomes even deeper when we ask whether a transition can be observed at all. To observe something, it must possess properties that can be measured. It must have characteristics that distinguish it from everything else. But what if the transition between moments is not a thing? What if it is not an object, a field, or a process in the conventional sense? What if it belongs to a category that our current concepts cannot adequately describe? This possibility may explain why the transition remains hidden. We may be searching for it as though it were an event occurring inside time, when in fact it may be connected to the very structure of time itself. Trying to observe it would be like trying to stand outside language in order to hear language being created. The framework required for observation may already depend upon the thing we are attempting to examine. Another clue comes from the present moment. We often imagine the present as a boundary between past and future, yet no matter how carefully we attempt to isolate it, the present seems impossible to capture. The instant we identify a moment, it has already become part of the past. The transition remains perpetually out of reach. It is as though reality always stays one step ahead of observation. This hidden quality appears throughout nature. Every event arrives from somewhere and continues into something else. Every cause produces an effect. Every state becomes another state. Yet the bridge itself remains invisible. The universe allows us to observe the results of change while withholding the transition that makes change possible. This is not a limitation of science. Perhaps it is a clue. Perhaps the fact that we never see the transition is telling us something important about reality. It may suggest that the deepest layer of existence is not composed of objects or events, but of relationships that cannot be directly observed from within the system they create. Whatever the answer turns out to be, one fact remains undeniable. The universe never shows us the transition. It shows us one moment, then another. It reveals the before and the after, but the bridge connecting them remains hidden in plain sight. And if that bridge truly exists, then understanding it may require looking beyond everything we currently assume about time, motion, and reality itself. Every event in the universe appears connected. A wave reaches the shore because it was moving moments earlier. A star shines because nuclear reactions continue inside it. A thought enters your mind because another thought came before it. Everywhere we look, reality seems to form an unbroken chain of causes and consequences. One instant becomes another so naturally that we rarely stop to question how the connection occurs. Yet hidden inside this apparent continuity is a mystery that physics has never fully explained. What actually links one instant of existence to the next? The question may seem unnecessary. Common sense immediately provides an answer. Time connects them. Reality moves forward. Events continue. But if we examine these responses carefully, we discover that they are descriptions rather than explanations. Saying that time carries one moment into another does not tell us how the carrying occurs. It simply assigns a name to the process. The deeper question remains untouched. What is the mechanism that allows existence to continue? Imagine looking at two photographs taken 1 second apart. In the first image, a bird is perched on a branch. In the second image, the bird has taken flight. We can easily infer what happened. The bird moved between the photographs, yet the movement itself is absent from both images. It exists only as an assumption connecting them. Now imagine applying this idea to reality itself. Every observation we make resembles a collection of snapshots. We observe the universe at one moment and then at another. The connection between those moments feels obvious, yet the actual bridge remains unseen. This hidden gap becomes more intriguing the longer we think about it. Suppose you could freeze the universe for an instant. Every particle, every star, every galaxy, every thought inside every conscious mind becomes completely motionless. Now imagine the universe restarting. What guarantees that reality resumes correctly? What ensures that every object continues its motion, every atom continues its vibration, and every process continues its evolution? The laws of physics describe what should happen, but they do not necessarily explain what physically links the frozen instant to the next one. This may sound like a purely philosophical puzzle, but it touches some of the deepest questions in modern science. Physics excels at describing states of reality. It tells us where objects are, how fast they move, how fields interact, and how particles behave. Yet, describing a sequence of states is not the same thing as identifying the mechanism that connects them. The equations work with extraordinary accuracy, but the bridge itself remains strangely absent from direct observation. Consider a digital animation. On a screen, characters appear to move smoothly, landscapes transform, entire worlds evolve before your eyes. Yet behind the scenes, the animation consists of separate frames. Each frame contains a complete state of the world. The illusion of continuity emerges because the frames are displayed rapidly enough for the viewer to perceive smooth motion. The audience experiences flow, but the system operates through a sequence of distinct states. This raises an unsettling possibility. Could reality itself be functioning according to a similar principle? If the universe were composed of individual states, then the most important mystery would not be the states themselves. It would be the process that connects them. What transforms one complete description of reality into the next? What carries information forward? What preserves continuity? These questions become especially important when we remember that information appears everywhere in physics. Every particle possesses properties. Every field contains structure. Every physical system stores information about its condition. Somehow that information remains coherent from one instant to another. The universe does not randomly reset itself. It preserves patterns, it preserves relationships, it preserves history. The existence of memory makes this mystery even more fascinating. Your brain contains records of previous experiences. Those records allow you to remember conversations, recognize faces, and maintain a sense of identity. Yet memory itself depends upon continuity. The physical structures storing information must persist through time. Something must connect the state of your brain a moment ago with the state of your brain now. Otherwise, experience would fragment into disconnected pieces. The fact that consciousness feels continuous suggests that some form of connection exists. The question is what that connection actually is. Quantum physics complicates the picture further. At microscopic scales, reality often behaves in ways that resist ordinary intuition. Particles do not always occupy definite locations. Systems can exist in superpositions of possibilities. Measurements reveal outcomes, yet the underlying processes remain difficult to visualize. Quantum theory provides mathematical tools capable of astonishing predictive power, but interpreting what those tools reveal about the nature of continuity remains an open challenge. The transition from possibility to outcome still generates debate among physicists and philosophers alike. Another way to approach the mystery is to think about causality. Every cause produces an effect. Strike a match and a flame appears. Push an object and it moves. A star explodes and new elements spread through space. Cause and effect seem inseparable from reality itself. Yet causality quietly assumes the existence of a connection between moments. A cause exists at one instant, an effect appears at another. Something must link them. Without that connection, the chain breaks. The universe would become a collection of isolated events with no meaningful relationships between them. This hidden link may be so fundamental that we overlook it entirely. Human beings naturally focus on objects and events because those are the things we can observe directly. We notice planets, particles, storms, and living organisms. We rarely pay attention to the continuity connecting them because continuity feels automatic. Yet many of the deepest discoveries in science have emerged from questioning assumptions that once seemed obvious. The motion of Earth, the nature of light, the structure of atoms, each became clearer only after people stopped taking familiar appearances for granted. The missing link between instants may belong to the same category of mystery. We assume it exists because reality appears coherent. We assume moments connect because experience appears continuous. But assumption is not an explanation. The universe continues moving forward, yet the bridge carrying it forward remains hidden. Some physicists suspect that the answer may involve structures deeper than space-time itself. Others believe the solution may emerge from quantum information. Some theories propose that reality is built from networks of relationships rather than objects. In these models, continuity may emerge from patterns that exist beneath ordinary experience. The familiar flow of time would then be a large-scale effect arising from more fundamental processes. Whatever the ultimate answer turns out to be, one fact remains remarkable. Humanity has learned how stars generate energy. We know how galaxies evolve. We have measured ripples in space-time and detected particles created billions of years ago. Yet the connection between one instant and the next remains one of the least understood aspects of existence. The universe continues its story without interruption, but the mechanism turning one page into the next remains hidden. That is why this mystery feels so profound. It is not hidden in a distant galaxy or buried inside a black hole. It is happening right now. Every second of your life depends upon it. Every thought, every memory, every heartbeat crosses the invisible bridge between moments. The bridge is always present. Yet we still do not know what it is. There is a possibility so strange that it almost sounds impossible when first encountered, yet it emerges naturally from the question we have been following from the beginning. If we cannot directly observe what connects one moment to the next, then perhaps the connection is not merely hidden. Perhaps something is missing. Perhaps reality is not presenting every stage of its own process. Perhaps the universe is skipping over pieces of existence so quickly or in such a fundamental way that we never noticed they were absent in the first place. This idea seems absurd. The world appears complete. You look around and everything feels continuous. A bird flies across the sky. Rain falls from clouds. Light travels from distant stars. Conversations unfold word by word. Nothing appears fragmented. Nothing appears incomplete. Reality feels whole. Yet history repeatedly teaches us that appearances can be misleading. There was a time when solid objects seemed truly solid. Today we know they are mostly empty space. There was a time when the night sky appeared fixed and unchanging. Today we know galaxies are moving through an expanding cosmos. Again and again, reality has revealed structures hidden beneath what appears obvious. Now consider the possibility that continuity itself may belong to this category. Imagine watching a spinning fan. When the blades rotate rapidly, they blur together. The gaps between them become difficult to perceive. The motion creates the appearance of a continuous surface, yet the continuity is not actually there. It emerges from limitations in observation. If the fan slowed down enough, the gaps would become visible. What appeared seamless would reveal itself as a sequence of separate structures. Some physicists wonder whether something similar could be happening at the deepest levels of reality. The universe may appear smooth because the processes underlying existence occur far beyond the resolution of human perception. The gaps, if they exist, may be hidden beneath scales so small that even our most advanced instruments struggle to approach them. This possibility becomes more interesting when we consider how information is processed. In everyday life, we assume that events unfold through a continuous chain of intermediate stages. If a person walks across a room, we imagine them occupying every position along the path. If a planet orbits a star, we imagine it passing through every point of its orbit. Continuity feels natural because our minds instinctively fill in the spaces between observations. Yet what if nature itself does not require every intermediate stage we imagine? Think about a digital image displayed on a screen. From a distance, the picture appears smooth and detailed. Curves look continuous, colors blend naturally, but when you zoom in far enough, the image breaks apart into individual pixels. The smoothness was never fundamental. It emerged from the arrangement of discrete elements. The eye interpreted the pattern as continuity because it lacked access to the deeper structure. Reality may possess a similar hidden architecture. Suppose existence is not evolving through a perfectly continuous process. Suppose there are fundamental steps occurring beneath spacetime itself. If those steps are small enough, every large-scale process would appear smooth. Stars would still shine. Galaxies would still rotate. Human beings would still experience continuity. Yet beneath the surface, reality could be progressing through discrete transitions rather than uninterrupted flow. This idea raises a fascinating question. If reality progresses through transitions, what happens during them? Is every possible stage included, or does the universe move directly from one valid state to another without passing through every intermediate condition we imagine? In mathematics, there are situations where systems can move between states without requiring every conceivable step along the way. Quantum mechanics contains examples that challenge classical notions of continuity. Certain quantum systems appear to transition between states in ways that do not resemble smooth motion through ordinary space. Physicists can predict the outcomes with extraordinary precision, but visualizing what occurs during the transition remains difficult. The deeper we explore these ideas, the more we encounter a recurring theme. Human intuition expects continuity because continuity defines everyday experience, yet nature repeatedly reveals behaviors that do not conform neatly to that expectation. Consider a movie again, but this time focus on what the audience never sees. Between each frame there is a gap. The viewer experiences a flowing scene because the mind integrates the sequence into motion. The missing intervals go unnoticed. The story feels continuous despite being constructed from separate images. If someone living inside the movie could observe only the frames themselves, they might assume the world flows smoothly. They would never suspect that hidden intervals exist between the states they experience. Now imagine applying that logic to reality itself. Could the universe contain hidden intervals that never enter conscious experience? Could existence consist of states connected by processes that remain inaccessible from within the system? Could there be structures, transitions, or informational updates occurring beneath perception, creating the appearance of continuity while concealing the deeper mechanism? These questions sound speculative, yet they emerge naturally from the limitations of observation. Every scientific measurement captures a state. We measure conditions before an event and after an event. We compare results, we build models. But the universe never hands us the transition itself. We infer its existence from the consistency of outcomes. The mystery becomes even deeper when we think about cause and effect. Every effect seems to emerge from a cause. A match ignites because it was struck. A tree grows because a seed was planted. A thought appears because neural activity occurs within the brain. Yet each of these explanations quietly assumes a continuous chain connecting one state to another. If reality contains hidden gaps, then the nature of causality itself may be more complicated than it appears. This does not mean causes and effects are illusions. It means the process connecting them may operate at a level we do not yet understand. Another intriguing possibility involves information. Modern physics increasingly treats information as a fundamental component of reality. Black holes, quantum systems, and space-time itself appear deeply connected to informational structures. If reality is fundamentally informational, then transitions between moments may involve transformations of information rather than motion through a continuous temporal medium. In such a universe, what appears to us as smooth evolution could actually be the result of underlying informational updates. The difference may sound subtle, but it changes the entire picture. Imagining reality flowing like a river, we begin imagining reality transforming through states. Instead of imagining time carrying events forward, we begin imagining information reorganizing itself according to deeper principles. What exists inside continuity? We begin asking whether continuity is the appearance created by something more fundamental. This possibility helps explain why the missing pieces, if they exist, remain invisible. We may be searching for them in the wrong way. We imagine hidden intervals as tiny regions of time waiting to be discovered, but the deeper structure may not resemble time at all. It may belong to a level of reality from which time itself emerges. If that is true, then the universe is not merely hiding information from us. The universe may be presenting existence through a framework that naturally conceals its own foundation, and that realization leads to an unsettling thought. The most important parts of reality are not the moments we experience. The most important parts are the unseen processes connecting them, the hidden architecture, the invisible transitions, the missing pieces that never appear inside observation, yet make every observation possible. If such pieces exist, then every second of your life depends upon them. Every memory, every heartbeat, every thought, every movement of every atom in your body. The universe continues presenting a coherent reality, yet the machinery producing that coherence remains hidden. And until we understand what lies beneath that hidden layer, one possibility remains open. Reality may not be showing us everything. It may be leaving out entire pieces of existence. Every event in the universe seems connected to another event. A star emits light. That light crosses space. It reaches a planet. It enters an eye. A thought forms. One thing appears to lead naturally into the next. Reality feels like a continuous conversation taking place across the cosmos. Causes become effects. Effects become new causes. The chain appears unbroken, yet hidden beneath this appearance is something profoundly strange. No matter how carefully we examine reality, there seems to be a silence between events that physics has never fully explained. This silence is not the absence of activity. It is not empty space. It is not a region waiting to be filled with matter or energy. It is something more subtle. It is the fact that every event appears complete when we observe it, yet the transition connecting it to the next event remains hidden. The universe constantly presents outcomes while keeping the process that links them largely out of sight. Imagine listening to a melody played on a piano. The music feels continuous. Notes blend into one another. A sequence of sounds becomes a coherent experience. Yet, if you isolate the individual notes, each exists separately. Between them lies a tiny interval. The listener rarely notices it because the mind naturally connects the sounds into a flowing pattern. The silence is present, but it disappears beneath the larger experience. Reality may contain a similar feature. Events emerge one after another so smoothly that the hidden interval between them becomes invisible. Think about a simple action such as raising your hand. It feels effortless. You decide to move, and the movement occurs. Yet beneath that experience lies an astonishing chain of processes. Electrical signals travel through neurons, muscles contract, countless molecular interactions take place. At every stage, one state becomes another. One event leads into the next, but the actual passage between states remains elusive. We observe the stages, we observe the results. The connection itself remains strangely silent. This pattern appears everywhere in nature. A lightning strike illuminates the sky. A chemical reaction transforms substances. A planet completes another fraction of its orbit. A black hole absorbs matter. Every event unfolds according to physical laws. Yet the universe never pauses to reveal the bridge between states. It presents the sequence while concealing the transition. The deeper we investigate this silence, the more unusual it becomes. Human intuition assumes that continuity requires visible connections. If one event leads to another, we expect to find a mechanism carrying the process forward. In many cases we do. We understand how forces operate. We understand how particles interact. We understand how energy transfers between systems. Yet when we push our questions to the deepest level, we encounter a boundary. Physics explains relationships between events with extraordinary success, but the existence of a relationship is not the same thing as witnessing the connection itself. Consider two dominoes standing side by side. One falls and strikes the other. The second domino falls. The sequence appears obvious, yet even here the connection consists of countless microscopic interactions occurring beneath ordinary perception. Zoom in far enough, and the simplicity disappears. The collision becomes a complex exchange of forces, fields, and particles. Zoom in even further and deeper questions emerge. What carries the information? What guarantees continuity? What preserves the chain of causality? These questions become even more intriguing in quantum mechanics. At the quantum level, reality often behaves in ways that challenge classical ideas about continuous processes. Particles appear in specific states, measurements produce outcomes, systems evolve according to mathematical rules. Yet many interpretations of quantum theory struggle to explain what occurs during the transition itself. Physicists can predict probabilities with astonishing accuracy, but the deeper meaning of the transition remains controversial. Imagine a quantum particle existing in multiple possible states before measurement. When an observation occurs, one outcome becomes actualized. This process is often described mathematically, but visualizing what physically happens during the transition is far more difficult. It is as though reality moves through a silent region where ordinary concepts fail. We know what happened before, we know what happens after. The bridge remains mysterious. This recurring silence may not be accidental. It may reveal something fundamental about how reality operates. Human beings evolved to perceive stable objects and predictable patterns. Our senses are not designed to reveal the deepest architecture of existence. They are designed to help us survive. As a result, we experience the world through a framework that emphasizes continuity and coherence. The hidden intervals disappear because our perception automatically assembles separate events into unified experiences. Movies provide a useful analogy. A film appears to contain continuous motion, yet it is constructed from individual frames. The viewer never experiences the gap between frames because the brain blends them together. The absence becomes invisible. If reality contains similar hidden intervals, our experience may conceal them in exactly the same way. The mystery grows deeper when we think about information. Every event carries information about the state of the universe. A star contains information. A molecule contains information. Your brain contains information. Somehow that information persists across time. Somehow the universe preserves structure from one moment to the next. Yet the process by which information crosses the silent boundary between states remains unclear. Imagine reading a sentence. Each word appears one after another. Meaning emerges from the sequence. Yet the meaning itself does not exist inside any individual word. It arises from the relationship between them. Reality may operate according to a similar principle. The events we observe may be like words in a larger cosmic language. The hidden silence between them may contain the structure that makes the entire sentence possible. Another way to think about this mystery is through causality. We often assume that causes naturally produce effects. Push an object and it moves, heat water and it boils, compress gas and its behavior changes. These relationships appear reliable because they occur consistently. Yet causality itself depends upon continuity. Something must carry the influence of the cause into the effect. The universe performs this task flawlessly, yet the mechanism remains hidden beneath the surface of experience. This hidden quality becomes even more striking when we consider the scale of the cosmos. Across billions of light years, galaxies evolve according to predictable patterns. Stars form, live, and die. Matter organizes itself into planets, oceans, and living systems. Everywhere we look, events remain connected across immense stretches of time and space. The coherence is astonishing, yet the universe never reveals the underlying process in a directly observable way. It simply presents the results. Some physicists suspect that this silence points toward a deeper layer of reality. Perhaps space-time itself emerges from more fundamental structures. Perhaps information exists within networks that operate beneath the level of ordinary observation. Perhaps continuity is not a basic feature of existence, but an emergent property arising from hidden relationships. In such a universe, the silence between events would not be empty. It would be filled with processes so fundamental that our current concepts cannot fully describe them. What makes this possibility fascinating is that it transforms the silence from a limitation into a clue. The fact that we never observe the transition directly may indicate that the transition belongs to a deeper level of reality. The missing bridge may not be hidden because it is small. It may be hidden because it exists beneath the framework through which observation itself becomes possible. The universe continuously moves from one event to another. Stars shine, particles interact, thoughts appear and disappear, life unfolds. Yet beneath every process lies a strange silence, a hidden interval, a missing bridge. We experience continuity without ever seeing what creates it. And perhaps that is the most remarkable part of the mystery. The silence is not rare. It is not confined to distant galaxies or extreme environments. It exists between every event in the cosmos, between every heartbeat, between every thought, between every movement of every particle. It is present everywhere, yet remains invisible. The universe never stops speaking through events, but the silence connecting them may be the deepest secret it has never revealed. Of all the mysteries surrounding time, there is one that seems almost impossible. It concerns something so familiar that we rarely think about it. You are experiencing it right now. Every sound you hear, every word you understand, every thought forming inside your mind appears to exist within it. We call it the present moment. It feels obvious. It feels immediate. It feels more real than anything else. Yet when physicists attempt to locate the present within the laws of nature, they encounter a surprising problem. They cannot find it. This sounds absurd. How can science fail to locate something we experience every second of our lives? Surely the present must be one of the easiest things to identify. After all, the past has already happened and the future has not happened yet. The present seems to sit directly between them. It appears to be the stage on which reality unfolds. But the deeper we investigate, the stranger the situation becomes. Imagine trying to point to the exact location of the present, not approximately, not within a second or a millisecond. The exact present moment, the instant dividing the past from the future. Where is it? The question sounds simple until you attempt to answer it. Suppose you define the present as a duration lasting 1 second. Immediately a problem appears. The beginning of that second belongs to the present, but so does the end. That means the interval contains earlier and later parts. It already includes a tiny past and a tiny future. It cannot be a single moment, so perhaps the present lasts a millisecond. The same problem remains, a microsecond. Again, the interval contains distinguishable parts. No matter how small the duration becomes, it can always be divided further. The present seems to retreat whenever we try to isolate it. It behaves like a boundary that cannot be captured. This puzzle has troubled philosophers for thousands of years, but modern physics inherited the same mystery. The more carefully scientists examine time, the harder it becomes to identify a special moment called now. One reason for this difficulty comes from the way physics describes reality. Most physical laws do not contain a moving present. They describe relationships between events. They describe how systems evolve. They calculate probabilities and interactions. Yet nowhere inside many of the fundamental equations do we find a special marker identifying the current moment of the universe. This is deeply strange because human experience revolves around the present. We remember the past, we anticipate the future, we act in what feels like moving now. The present appears to occupy the center of existence. Yet physics often treats all moments as coordinates within a larger structure, rather than assigning special importance to one particular instant. Imagine a map. A map contains cities, rivers, mountains, and roads. Every location exists simultaneously on the page. The map does not contain a special location labeled current location unless an observer adds one. Similarly, many physical descriptions of spacetime contain events distributed throughout a four-dimensional structure. The equations describe the landscape. They do not automatically identify a moving present traveling through it. This realization becomes even more unsettling when we consider Einstein's theory of relativity. Before Einstein, many scientists assumed that the universe shared a universal clock. Everyone would agree about what was happening at a particular moment. There would be a single cosmic presence stretching across existence. Relativity changed that picture completely. According to Einstein, observers moving differently can disagree about whether certain events occur simultaneously. What appears to be happening now from one perspective may not appear simultaneously from another. The concept of a universal present begins to dissolve. Imagine two observers separated by enormous distances and moving relative to one another. Because information cannot travel faster than light, there is no absolute way to synchronize every event across the universe. Each observer constructs their own understanding of simultaneity. The result is astonishing. Physics no longer supports the idea of a single cosmic now shared equally by everything in existence. The implication is difficult to absorb. If there is no universal present, then what exactly are we experiencing? The mystery deepens when neuroscience enters the conversation. Your experience of the present feels immediate, but your brain does not process information instantly. Light enters your eyes. Signals travel through nerves. Different regions of the brain analyze different aspects of the information. These processes require time. By the time you become consciously aware of an event, fractions of a second have already passed. The present you experience may already belong partly to the past. This is not speculation. Experiments repeatedly show that perception involves processing delays. Your brain gathers information across brief intervals and assembles it into a coherent experience. The present may function less like a razor-thin instant and more like a constructed window integrating information over time. Imagine watching a live sports broadcast. What appears live may actually be delayed by several seconds. The audience experiences the event as immediate, even though the information has already traveled through multiple systems before reaching them. Consciousness may operate in a somewhat similar way. The now you experience could be a carefully assembled representation, rather than a direct encounter with an exact instant of reality. This possibility raises an extraordinary question. If the present is partly a construction created by the brain, then does the present exist independently of conscious experience? Or is the present something minds generate while interacting with the universe? Physicists and philosophers continue debating this question because neither answer feels entirely satisfactory. The mystery becomes even stranger when we consider the smallest scales of nature. Suppose reality possesses a fundamental limit beyond which time cannot be meaningfully divided. Some theories suggest that Planck-scale physics may introduce such limits. If that is true, then the present might not be infinitely divisible after all. Yet even this possibility does not solve the problem. It merely moves the mystery to a different level. We still do not know how a single fundamental instant becomes the next one. The deeper we investigate, the more elusive the present becomes. It cannot be isolated as a duration because every duration contains smaller parts. It cannot easily be defined as an instant because an instant appears to possess no duration at all. It cannot be identified as a universal cosmic moment because relativity removes the concept of universal simultaneity. It cannot be reduced entirely to perception because physical events occur regardless of whether humans observe them. The present remains suspended between physics, philosophy, and consciousness. This uncertainty creates a fascinating possibility. The reason physicists cannot locate the present is because the present is not a fundamental feature of reality. Reality does not contain a movement now. The present emerges from deeper processes hidden beneath space-time itself. Think about a wave moving across the ocean. The crest appears to travel, yet the water molecules themselves do not travel with the wave in the way we imagine. The moving crest emerges from underlying interactions. The phenomenon is real, but it is not fundamental. The present may resemble that moving crest. Something real, something experienced, yet not necessarily a basic ingredient of the universe. If this possibility is correct, then the inability to locate the present is not a failure of science. It is a clue. It suggests that we may be searching for the wrong thing. We keep looking for a moving moment because human experience presents one. Reality itself may operate according to deeper principles, and that brings us closer to the mystery hidden at the center of this entire discussion. If the present cannot be located, if the transition between moments cannot be observed, and if continuity itself remains unexplained, then perhaps the universe is doing something far stranger than simply moving through time. Reality is being updated, not continuously, not visibly, but through a hidden mechanism operating beneath the surface of existence. And if such a mechanism exists, it may be the closest thing we have to an answer for what connects one moment to the next. If there is one question that quietly sits beneath everything we have explored so far, it is this: what keeps reality going? Not what reality contains, not what happened in the past, not what will happen in the future, but what allows existence itself to continue from one instant to the next. Most people never think about this question because continuity feels automatic. The universe appears stable, stars shine, atoms interact, thoughts emerge, life unfolds. Everything seems to proceed naturally, yet when we look closely, we discover something remarkable. Physics describes the state of reality at different moments with extraordinary precision, but the deeper mechanism carrying reality from one state into the next remains surprisingly mysterious. Imagine opening a book and reading a story. Each page contains information. Characters exist in specific situations. Events unfold. As you turn the pages, the narrative progresses, yet the story itself is not moving. The pages already exist. The experience of progression arises because the reader encounters them sequentially. Now imagine reality itself. Could the universe be operating according to a hidden process that continually presents new states of existence, creating the appearance of flowing time? This idea sounds unusual, but it emerges naturally from one of the strangest observations in modern science. The deeper physicists investigate reality, the more fundamental information appears to become. Matter contains information. Energy contains information. Quantum systems contain information. Even black holes, once thought to destroy information, now appear deeply connected to it. Again and again, reality reveals itself not merely as a collection of objects, but as a structure built from relationships and informational patterns. This has led some researchers to ask a fascinating question. What if the universe is not fundamentally made of things? What if it is fundamentally made of information? And if information lies at the foundation of reality, then perhaps the most important process occurring in the cosmos is not motion, but transformation. Not movement through time, not objects traveling through space, but information updating from one state into another. To understand why this possibility matters, consider how a computer simulation operates. A simulated world appears continuous to the characters inside it. Mountains stand still, rivers flow, objects move. Events unfold naturally, yet beneath the appearance of continuity, the system continually updates information. One state becomes another according to underlying rules. The characters, if conscious, would experience a seamless world. They would never directly observe the updating process itself. They would only experience the results. Some physicists wonder whether reality may contain something analogous, not necessarily a literal computer, not necessarily a simulation created by an external intelligence, but a hidden mechanism responsible for updating the informational structure of existence, a process that continually transforms one state of the universe into the next. This sounds speculative. Yet the question arises because physics already encounters similar challenges. Take quantum mechanics. A quantum system can be described mathematically by a wave function representing possibilities. The equations successfully predict how those possibilities evolve. Yet when a specific outcome appears, interpretation becomes more difficult. What exactly happened? What transformed possibility into reality? What selected one outcome from many? Different interpretations offer different answers. Yet the deeper question remains unresolved. Something appears to occur between potential states and actual states. Something connects them. Something updates reality. This hidden process becomes even more mysterious when we think about the continuity of the universe itself. Right now, every particle in your body possesses specific properties. Every atom occupies particular relationships. Every memory stored inside your brain exists within an enormously complex arrangement of matter and information. A moment from now, those arrangements will be slightly different. Neurons will have fired, molecules will have shifted, particles will have interacted, the universe will have changed. But what guarantees continuity? What ensures that the future state emerges from the present state rather than becoming completely random? The laws of physics describe the relationships between states, but the existence of continuity itself remains one of the deepest assumptions built into our understanding of reality. Perhaps continuity feels mysterious because we are asking the wrong question, asking what moves through time. Perhaps we should ask what maintains coherence. How does the universe preserve information across successive states? How does reality avoid becoming fragmented? How does the cosmos maintain its remarkable consistency? Think about a symphony orchestra. Hundreds of individual sounds emerge from different instruments, yet they combine into a coherent piece of music. The coherence does not arise by accident. It emerges because the sounds are organized according to deeper relationships. Reality may operate similarly. The universe may not require a continuous temporal river carrying events forward. Instead, coherence itself may be the fundamental feature. The hidden mechanism may not transport reality through time. It may generate the consistency that allows time to appear. This possibility becomes even more intriguing when we consider the nature of physical law. Scientists often describe laws of physics as rules governing the behavior of matter and energy. Yet, there is something remarkable about these laws. They remain consistent across vast stretches of space and time. The same principles governing particles inside your body also govern distant galaxies billions of light years away. The same equations apply across the observable universe. This consistency suggests that reality possesses an underlying order connecting everything together. But where does that order reside? What enforces it? Why does the universe follow stable patterns rather than descending into chaos? Some researchers believe the answer may lie in structures deeper than space-time itself. Certain approaches to quantum gravity suggest that space and time may emerge from more fundamental relationships. Other theories propose that information forms the true foundation of existence. In these frameworks, the visible universe becomes a surface phenomenon emerging from hidden processes beneath ordinary observation. The updating mechanism would not exist inside space-time. Space-time itself would emerge from the mechanism. This is an extraordinary reversal of perspective. Most people imagine time as the stage upon which events occur. These theories suggest that time may be one of the events, not the foundation, not the container, a product of deeper activity. If this is true, then the universe may not be flowing through time at all. The universe may be generating time, moment by moment, state by state, relationship by relationship. This possibility helps explain why the transition between moments remains so difficult to observe. The updating process may occur beneath the level at which time exists. Trying to observe it from within time would be like trying to see the foundations of a building while standing inside one of its rooms. The structure supporting everything remains hidden because it operates beneath the framework of experience itself. Another clue comes from consciousness. Your awareness feels continuous. You experience a persistent sense of self moving through time. Yet neuroscience reveals that the brain constantly reconstructs experience from streams of information. Perception is assembled. Memories are integrated. Sensory signals are processed. The continuity you experience may itself emerge from an ongoing process of informational updating. In other words, the feeling that reality flows smoothly may arise because your mind continually generates coherence from changing information. The universe may be doing something similar at a larger scale, not through consciousness necessarily, but through hidden principles preserving relationships across successive states. The deeper we investigate, the more the mystery changes shape. We began by asking what connects one moment to the next. Now the question becomes even stranger. What if moments themselves are products of a deeper process? What if reality is continually updating according to principles hidden beneath space and time? What if the continuity we experience is not fundamental, but emergent? The universe never shows us the mechanism directly. It shows us stars, planets, particles, galaxies, thoughts, events, but the process generating continuity remains invisible. And perhaps that invisibility is not a failure of observation. Perhaps it is evidence that the mechanism operates at a level more fundamental than anything we normally call reality. If such a mechanism exists, then every event in the cosmos depends upon it. Every heartbeat, every memory, every movement of every particle, every galaxy drifts through the darkness between the stars. All of it would rely upon an unseen process quietly maintaining the coherence of existence. A process we never observe directly. A process hidden beneath every moment. A process that may be the closest thing the universe has to an answer for what connects one instant to the next. And if that hidden mechanism truly exists, then an even stranger possibility begins to emerge. Reality is not updating continuously at all. Perhaps it is happening through invisible jumps that occur too quickly, too deeply, or too fundamentally for us to notice. And that possibility leads directly into the next mystery. The universe appears smooth. That simple observation sits at the foundation of nearly everything we believe about reality. Planets move through space without interruption, rivers flow continuously, light travels across vast distances, thoughts emerge in a seemingly unbroken stream. Every experience of daily life encourages the same conclusion. Existence unfolds smoothly from one moment to the next. But what if that impression is wrong? What if continuity is not a fundamental feature of reality? What if existence is actually happening through invisible jumps so small, so rapid, and so deeply hidden that no human being has ever directly perceived them? This possibility sounds strange because it conflicts with intuition. Human experience is built around continuity. We do not experience reality as a sequence of disconnected pieces. We experience movement, change, and duration as continuous processes. Yet history repeatedly shows that intuition is not always a reliable guide to the deepest levels of nature. For centuries, people assumed that matter was continuous. A stone appeared solid, the water appeared smooth, the air seemed uniform. But as science advanced, we discovered atoms, then particles, then quantum fields. What looked continuous often turned out to be composed of smaller structures hidden beneath perception. The same pattern may apply to time itself. Imagine standing on a beach and looking out at the ocean. From a distance, the water appears smooth. The surface forms elegant curves and flowing waves. Yet move closer and the picture changes. The wave is not a single object. It is a collective behavior emerging from countless individual molecules interacting with one another. Now imagine taking that idea even further. What if the flow of reality itself is an emergent phenomenon? What if the continuity we experience arises from underlying transitions occurring beneath our ability to observe them? To understand why physicists even consider such possibilities, it helps to think about motion. Suppose you watch a bird fly across the sky. The movement appears continuous. The bird seems to occupy every position along its path. Your mind naturally fills in the entire trajectory. But what do you actually observe? You never see every possible position. Your eyes collect information at specific intervals. Your brain assembles those intervals into a coherent experience. The continuity exists within perception. This does not mean the bird is not moving continuously. It means our experience of continuity already involves reconstruction. The brain is constantly creating smoothness from limited information. This becomes even more interesting when we examine how modern technology works. Consider a digital video. To the viewer, motion appears fluid. Characters walk naturally. Vehicles move across landscapes. Entire worlds unfold without interruption. Yet beneath the appearance of continuity lies a sequence of frames. Each frame is a complete state. The motion emerges because the frames are displayed rapidly enough for the mind to blend them together. The audience experiences flow. The system operates through transitions. Now imagine applying this concept to the cosmos. Not as a literal claim that reality is a video, but as a thought experiment. Could existence itself be progressing through states? Could the universe be evolving through fundamental transitions hidden beneath ordinary observation? Some physicists have explored exactly this possibility. One reason involves the concept of quantization. Quantum theory revealed that many aspects of nature do not vary continuously. Energy often appears in discrete amounts. Certain physical properties occur in distinct states. The quantum world repeatedly challenges the assumption that everything must change smoothly. This does not automatically imply that time is discrete, but it opens the door to the possibility. If energy can be quantized, if physical states can be quantized, then perhaps reality contains deeper structures that also operate through discrete transitions. The idea becomes especially fascinating when we consider the smallest scales known to physics. As we approach the Planck scale, our current theories begin to break down. The familiar picture of space-time becomes uncertain. Distances lose their ordinary meaning. Durations become difficult to define. The mathematical tools that describe larger scales stop providing clear answers. This breakdown has led some researchers to wonder whether space-time itself may emerge from more fundamental ingredients. If that is true, then continuity may not exist at the deepest level. Instead, reality may be built from structures that give rise to continuity only when viewed from a larger perspective. Think about a photograph displayed on a screen. From across the room, the image appears perfectly smooth. Move closer and individual pixels become visible. The continuity was real at one scale and absent at another. Reality may possess a similar layered structure. The smooth universe we experience could emerge from discrete foundations hidden far beneath perception. If existence truly unfolds through invisible jumps, an obvious question arises. Why don't we notice? The answer may be simple. The jumps, if they exist, could occur at scales so small that every known process naturally averages them into apparent continuity. Imagine trying to detect individual grains of sand while observing an entire desert from orbit. The details disappear beneath the larger pattern. Fundamental transitions could become invisible within the enormous complexity of ordinary experience. Every atom in your body contains unimaginable amounts of activity. Every second involves countless interactions. The hidden structure would be buried beneath layers of larger phenomena. Another reason we may fail to notice such jumps is that consciousness itself may depend upon them. Suppose your thoughts, perceptions, and memories emerge from the same underlying processes shaping reality. Then your awareness would update alongside everything else. You would have no external reference point from which to observe the transitions. The jumps would not merely happen around you, they would happen within the very system producing your experience. This creates a remarkable possibility. Continuity feels seamless, because consciousness participates in whatever process generates it. You do not observe the transition because you are part of the transition. You move with it. You emerge from it. You experience only the resulting continuity. The deeper mystery concerns what actually occurs during these hypothetical jumps. If reality advances through states, what determines the next state? What preserves information? Farno, what maintains causality? Why does the universe remain coherent rather than becoming random? These questions reveal why the idea remains speculative. Proposing invisible jumps does not solve the mystery, it merely shifts the mystery to a deeper level. Asking what connects moments, we begin asking what governs transitions between states. The need for an underlying mechanism remains, yet many researchers find this perspective valuable because it reframes the problem. Rather than assuming continuity as a fundamental fact, it treats continuity as something requiring explanation. This shift opens new possibilities for understanding time, information, and space-time itself. Certain approaches to quantum gravity already move in this direction. Some models describe reality through networks, relationships, or informational structures from which space and time emerge. Others suggest that geometry itself arises from deeper connections. Although these ideas remain incomplete, they share a common theme. The universe we experience may not be the deepest level of reality. What appears continuous may emerge from processes hidden beneath it. What appears stable may arise from continual transformation. What appears smooth may be built from transitions too fundamental to observe directly. The implications are extraordinary. Every sunrise, every heartbeat, every memory, every galaxy drifts through cosmic darkness. All could depend upon hidden transitions occurring beneath the surface of existence, not transitions we witness, not transitions recorded by ordinary experience, but transitions nonetheless. The universe would resemble a story continually renewing itself, not through visible movement alone, but through deeper processes maintaining coherence from one state to the next. And if that possibility sounds strange, it leads directly into an even more profound mystery. Because even if reality unfolds through invisible jumps, we still have not answered a crucial question. What actually links causes to effects? What carries influence across the hidden boundary between one event and another? Because somewhere between every cause and every consequence lies a mystery that physics still struggles to fully explain. And that mystery may be hiding in plain sight between every event that has ever occurred in the universe. The oldest assumptions human beings make about reality is that causes produce effects. We learn this idea so early in life that it becomes almost invisible. A glass falls from a table and shatters on the floor. A seed is planted and eventually becomes a tree. A stone is thrown into a pond and ripples spread across the water. Everywhere we look, events appear connected through chains of cause and effect. The universe seems to operate like an enormous sequence in which one thing leads naturally into another. Because this pattern appears so reliable, most people never stop to ask a deeper question. What actually connects a cause to its effect? The answer seems obvious. The cause comes first. The effect comes later. Time carries the influence forward. Yet if we examine this explanation carefully, we discover that it contains the very mystery we are trying to understand. Saying that time carries a cause into an effect does not explain how the carrying happens. It simply assigns a label to the process. The deeper mechanism remains hidden. Imagine a row of dominoes standing upright. When the first domino falls, it strikes the second strikes the third. Eventually, the entire chain collapses. This example is often used to illustrate causality because it appears simple and direct. Yet beneath the simplicity lies a remarkable complexity. The first domino does not magically communicate with the last. Instead, a sequence of interactions occurs. Forces are transferred. Matter responds. Energy moves through the system. The visible chain of events conceals countless microscopic processes operating beneath ordinary perception. Now imagine zooming in further. The collision between two dominoes becomes a vast landscape of atoms interacting through electromagnetic forces. Zoom in again and particles appear. Zoom in again and quantum fields emerge. The deeper we travel, the more difficult it becomes to identify a single point where the cause transforms into the effect. The process becomes distributed across layers of reality. The connection remains present, yet its true nature becomes increasingly difficult to locate. This difficulty reveals something important. Cause and effect may not be as simple as they appear. The universe presents them as a seamless relationship, but the underlying mechanism remains surprisingly elusive. We observe the beginning. We observe the outcome. The bridge connecting them often disappears into deeper structures. The mystery becomes even more profound when we consider that modern physics does not always describe reality in terms of direct causes producing direct effects. At the quantum level, events are often described through probabilities rather than certainties. A particle may possess several possible outcomes before measurement occurs. Mathematics predicts the probabilities with extraordinary accuracy, but the exact process by which one possibility becomes reality remains the subject of ongoing debate. This creates a fascinating tension. Human intuition expects a clear chain linking every cause to every effect. Quantum mechanics sometimes suggests that reality operates according to principles that do not fit comfortably within that framework. The universe still produces outcomes, but the path connecting possibility to actuality becomes far less obvious. Consider a simple example. Imagine releasing a ball from your hand. Classical physics allows us to predict where it will fall with remarkable precision. The cause appears clear. Gravity pulls the ball downward. The effect follows naturally. Yet even here, the deeper story involves layers of complexity hidden beneath the surface. Gravity itself remains one of the least understood fundamental phenomena in physics. We can describe its effects with extraordinary success, but explaining what gravity actually is remains an active area of research. Once again, the universe provides the result while concealing part of the underlying mechanism. This pattern appears throughout science. We know how to predict many processes. We know how to calculate outcomes. We know how systems evolve. Yet the deeper connection between causes and effects often retreats behind the mathematical descriptions. The equations work. The mechanism remains partially hidden. Another way to appreciate the mystery is to think about information. Every cause contains information about a system. Every effect reflects information about what came before. Somehow that information survives the transition. Somehow it moves through reality without becoming lost. When a wave spreads across the ocean, information about the disturbance propagates through the water. When light travels across space, information about distant stars reaches our eyes. When memories form inside the brain, information about previous experiences becomes embedded within neural structures. The persistence of information is one of the most remarkable features of the universe. It allows continuity, it allows history, it allows identity. Without it, reality would dissolve into disconnected events. Yet the process by which information crosses from one state into another remains one of the deepest questions in physics. Black holes provide an extraordinary example of this mystery. For decades, physicists believed that information falling into a black hole might be permanently destroyed. This idea created a major conflict with quantum mechanics, which strongly suggests that information should be preserved. The resulting debate became known as the black hole information paradox. Years of research eventually convinced many scientists that information is not destroyed after all. Yet explaining exactly how information survives remains an active area of investigation. The significance of this problem extends far beyond black holes. It reveals how fundamental information may be to reality itself. If information cannot simply vanish, then continuity may depend upon deeper informational structures linking one state of the universe to another. The cause-effect relationship may not be carried solely by time. It may be carried by the preservation and transformation of information. This possibility changes the way we think about causality. Instead of imagining causes pushing effects through time, we begin imagining reality as a network of relationships in which information continually transforms while preserving coherence. The visible chain of events becomes the surface expression of deeper informational processes. The mystery grows even larger when we examine the role of the present moment. Every cause belongs to what we call the past. Every effect belongs to what we call the future. Yet, as we explored earlier, physics struggles to define the present itself. If the present cannot be clearly located, then where exactly does the transition from cause to effect occur? At what point does the future become the present and then become the past? The question sounds straightforward, yet it leads directly into one of the deepest puzzles in science. The boundary appears obvious from experience, but it remains difficult to identify within the laws of nature. Once again, the connection hides behind the appearance of continuity. Imagine reading a sentence. Each word contributes to the meaning of the whole. The meaning emerges because the words remain connected through relationships. If the words were completely isolated from one another, the sentence would lose coherence. Reality may operate in a similar way. Causes and effects may not be separate events linked by a temporal bridge. They may be components of larger structures whose coherence emerges from relationships extending across time. Some interpretations of modern physics move in exactly this direction. Certain theories suggest that reality is fundamentally relational. Objects do not possess meaning independently. Events do not exist in isolation. Instead, everything derives significance from networks of connections. In such a universe, causality may emerge from patterns of relationships rather than from simple chains extending through time. This perspective helps explain why the mystery remains so difficult. We keep searching for a bridge between causes and effects because we imagine them as separate things requiring connection. The deeper reality may not be organized that way. The connection may not be something added afterward. The connection may be fundamental. Even if this possibility proves correct, the mystery does not disappear. It merely shifts to a deeper level. We still need to understand how the relationships themselves arise. We still need to explain why reality remains coherent. We still need to discover what preserves continuity across the vast network of events that make up the universe. And that brings us back to the central question of this entire journey. Every cause becomes an effect. Every effect becomes a new cause. The chain extends across galaxies, across billions of years, and across every process occurring in nature. Yet the universe never directly reveals what carries the connection forward. The bridge remains hidden beneath the events it links. The missing mechanism is woven into space-time itself. Perhaps it emerges from information. Perhaps it belongs to a deeper layer of reality that physics has not yet uncovered. Whatever the answer turns out to be, one fact remains extraordinary. The universe depends upon countless connections between causes and effects, yet the nature of those connections remains one of the greatest unsolved mysteries in science. And if the bridge between causes and effects is still hidden from us, then another possibility emerges. The universe may not only be connecting events, it may also be selecting which information survives between them. It may be filtering reality in ways we do not yet understand. And that possibility leads directly into an even stranger question. What if the universe is not only connecting moments? What if it is skipping information along the way? When people think about mysteries in physics, they usually imagine hidden particles, unexplored galaxies, black holes, or dimensions beyond ordinary perception. Rarely do they consider information itself as one of the greatest mysteries in existence. Information sounds abstract, It feels less tangible than matter or energy. Yet over the last century, physics has undergone a remarkable shift. More and more researchers have begun to suspect that information may not merely describe reality. It may be one of the most fundamental ingredients from which reality is built. This change in perspective has led to an extraordinary possibility. If information lies at the foundation of existence, then understanding reality may require more than understanding matter and energy. It may require understanding how information moves, transforms, persists, and even disappears. And once that question is taken seriously, another possibility emerges that is both fascinating and unsettling. What if the universe is not preserving every piece of information in the way we imagine? What if reality is continuously filtering, compressing, or skipping information as it moves from one moment to the next? This idea seems impossible. Modern physics generally assumes that information is conserved. The state of a physical system contains information, and that information should not simply vanish without explanation. Yet the deeper scientists investigate reality, the more complicated the situation becomes. The universe often behaves in ways that suggest that the information available to observers is only a fraction of the information that may actually exist. Consider your own experience right now. The room around you contains an unimaginable amount of information. Every atom possesses properties. Every photon carries data about its origin. Every sound wave contains intricate details. Yet your conscious mind processes only a tiny portion of this information. Most of it never reaches awareness. Your brain constantly filters reality, selecting certain patterns while ignoring countless others. Without this filtering process, perception would become overwhelming. The universe itself may operate in a somewhat similar manner. Imagine observing a forest from an airplane. You see broad patterns. You see rivers, mountains, and large clusters of trees. What you do not see are individual leaves, insects, and microscopic structures hidden beneath the canopy. The information exists, but your perspective compresses it into a simpler picture. Reality may be doing something analogous at every level. This idea becomes especially important when physicists study entropy and information theory. Entropy is often described as a measure of disorder, but another way to think about it is as a measure of missing information. When a system becomes more disordered, our ability to describe its exact microscopic state decreases. The information is not necessarily destroyed, but it becomes dispersed in ways that are increasingly difficult to recover. A simple example helps illustrate the idea. Imagine dropping a drop of ink into a glass of water. Initially, the ink occupies a specific location. Its position can be described with relative ease. As the ink spreads throughout the water, the information about its precise original arrangement becomes increasingly difficult to reconstruct. The information still influences the system, but it has become distributed across countless microscopic details. Now expand this idea to the scale of the universe. Every event generates information. Every interaction alters informational relationships. Every particle collision, every chemical reaction, every movement of every galaxy contributes to an ever-changing informational landscape. The amount of information involved is staggering beyond comprehension. It raises a profound question. How much of that information actually remains accessible as reality evolves? The question became especially important when physicists began studying black holes. For many years, black holes appeared to present a serious challenge to the principle of information conservation. Objects fall into a black hole. Matter disappears beyond the event horizon. If the black hole eventually evaporates through a process known as Hawking radiation, what happens to the information describing everything that fell inside? This problem became known as the black hole information paradox. It generated decades of intense debate because the implications were enormous. If information can truly disappear, then some of the most fundamental assumptions in physics may be incomplete. If information cannot disappear, then reality must possess hidden mechanisms, preserving it even under the most extreme conditions. Although many physicists now believe information is ultimately preserved, the journey toward that conclusion revealed something important. Information occupies a far more central role in reality than previously imagined. The universe appears deeply concerned with how information is stored, transformed, and transmitted. This realization leads directly back to our central mystery. If every moment depends upon information inherited from previous moments, then what exactly crosses the boundary between one instant and the next? What survives the transition? What is preserved? What is discarded? Suppose reality does not transfer every detail perfectly from one state to another. Suppose some information becomes inaccessible. Suppose some information is compressed into larger patterns. Suppose some information exists only at levels we cannot observe. From our perspective, it might appear as though the universe is skipping information. This does not necessarily mean information is literally destroyed. The situation may be more subtle. The universe may be presenting a simplified version of deeper processes. Much as a map omits countless details while preserving essential structure, reality may reveal only certain aspects of its underlying informational architecture. Consider a digital photograph again. The image contains information, but it is not an exact representation of everything in the original scene. Details are compressed, certain features are emphasized, others disappear. Yet the resulting image remains useful because it preserves relevant patterns. The universe may operate according to similar principles. The reality we experience could represent a large-scale informational description rather than a complete account of every underlying process. If this is true, then continuity itself may involve forms of informational compression. The smooth flow of experience may emerge because deeper details become hidden beneath larger structures. Quantum mechanics introduces another fascinating layer to the discussion. Quantum systems often contain information in forms that resist ordinary description. Entangled particles, for example, exhibit correlations that cannot be understood solely by examining each particle individually. The information describing the system exists within relationships rather than isolated objects. This suggests that information may be distributed throughout reality in ways that challenge traditional assumptions. What appears missing from one perspective may remain present within larger relational structures. The deeper scientists investigate quantum information, the more extraordinary the implications become. Some researchers now suspect that space-time itself may emerge from informational relationships. According to certain theoretical approaches, geometry, distance, and even temporal order may arise from networks of information existing beneath conventional reality. If such ideas prove correct, then the question of skipped information becomes even more profound. The universe may not simply process information. The universe may be made from information. And if reality emerges from informational structures, then understanding what happens between moments requires understanding how those structures evolve. Imagine reading a novel. The story contains far more meaning than any individual word. The information emerges from relationships spanning chapters, characters, and events. If you focus on a single sentence, much of the larger structure remains hidden, yet it still influences everything that happens. Reality may possess a similar architecture. The information visible within any single moment may represent only a small portion of a much larger informational framework extending across time and space. This possibility helps explain why the connection between moments remains so difficult to observe directly. We may be looking at isolated pages while the deeper story exists within relationships spanning the entire book. The mystery becomes even more intriguing when we consider human memory. Your sense of personal identity depends upon informational continuity. Memories preserve patterns linking past experiences to present awareness, yet memory is never a perfect recording. Information is constantly reconstructed, reorganized, and interpreted. What survives is not an exact copy of every detail, but a meaningful structure connecting experiences across time. The universe may preserve information in a comparable way, not necessarily by maintaining every microscopic detail in accessible form, but by preserving larger structures that allow continuity to emerge. If that is the case, then what appears to us as skipped information may actually be information hidden within deeper layers of reality. The distinction is important. Something may seem absent because it has vanished, or it may seem absent because it exists beyond the level at which we are observing. Modern physics has repeatedly shown that reality contains hidden layers beneath ordinary experience. Atoms exist beneath matter. Quantum fields exist beneath particles. Space-time may itself emerge from deeper structures still unknown. Information could follow the same pattern. The details connecting moments may not be missing at all. They may simply reside within levels of reality that remain beyond our current understanding. Yet regardless of how the mystery is ultimately resolved, one fact remains extraordinary. Every moment of existence depends upon information crossing an invisible boundary between states. The universe continually preserves enough structure to maintain coherence while transforming itself into something new. How that transformation occurs remains one of the deepest unanswered questions in science. And as we follow that question further, we arrive at a place where some of our most familiar concepts begin to fail. Time becomes uncertain. Motion becomes difficult to define. Reality itself starts to lose the stable framework we normally take for granted, because there may exist a region where the assumptions underlying continuity, causality, and information no longer function in the ways we expect. A place where the ordinary rules of existence begin to break down. And that is where the next stage of the mystery begins. Throughout this journey, we have followed a question that initially seemed simple. We wanted to know what connects one moment to the next. Along the way, we encountered hidden assumptions about time, unexplained transitions between events, missing informational links, and the possibility that reality itself may operate through processes hidden beneath ordinary perception. Yet all of these mysteries eventually point toward the same destination. They point toward a boundary where our most trusted concepts begin to fail. This boundary is not a physical location that can be marked on a map. It is not a distant region of the cosmos waiting to be explored by a spacecraft. It is something far more unusual. It is a limit within our understanding of reality itself. It is the place where time, motion, and even the structure of existence become difficult to define. Human beings naturally assume that reality is built upon stable foundations. We imagine space as a stage upon which events occur. We imagine time as a flow carrying those events forward. We imagine motion as the process of objects changing position within that framework. These ideas feel so natural that they seem inseparable from existence itself. Yet modern physics has repeatedly shown that the deeper we investigate reality, the less secure these assumptions become. Consider motion. It appears straightforward. A planet moves around a star. A car travels along a road. A photon crosses space. Everything seems to involve objects occupying one location and then another. But what exactly is motion? If we attempt to break it into its smallest components, the concept begins to slip away. At any given instant, an object occupies a specific position. During that instant, it is simply where it is. If we freeze reality completely, motion disappears. The object is not moving, it is merely occupying a location. Now imagine another instant immediately afterward. The object occupies a slightly different position. We can compare the two states and describe the change. Yet the actual process connecting them remains difficult to isolate. This problem has fascinated thinkers for thousands of years. Ancient philosophers such as Zeno recognized that motion contains a hidden mystery. His famous paradoxes were designed to expose how difficult it is to explain movement using ordinary concepts. Although mathematics eventually provided tools for describing continuous change, the deeper philosophical puzzle never entirely disappeared. What exactly carries an object from one position to another? The question becomes even more difficult when combined with modern physics. At large scales, relativity describes motion through spacetime with extraordinary accuracy. At small scales, quantum mechanics governs the behavior of particles. Both theories work remarkably well within their respective domains. Yet when physicists attempt to combine them, problems emerge. The place where these problems become most severe is often associated with the Planck scale. This scale represents a regime so extreme that our current theories begin to lose their predictive power. Distances become unimaginably small. Durations become extraordinarily brief. The familiar geometry of spacetime may cease to function in recognizable ways. At these scales, asking ordinary questions becomes surprisingly difficult. What is the position of a particle? What is the duration of an event? What is the exact structure of space? What is the exact structure of time? The answers become increasingly uncertain. Imagine using a map to navigate a city. The map works beautifully at ordinary scales. Streets, buildings, and landmarks appear in predictable locations. But suppose you continue zooming in beyond the level for which the map was designed. Eventually, the representation stops making sense. The symbols no longer correspond to reality in a useful way. The map has reached the limits of its applicability. Something similar may happen with our physical theories. Space and time are the maps through which we understand reality. At everyday scales, they function extremely well. Yet near the deepest levels of existence, those maps may cease to describe what is actually happening. This possibility is one reason physicists suspect that space-time may not be fundamental. The idea sounds radical because space-time appears to be the framework containing everything else. Yet several approaches to quantum gravity suggest that space and time themselves may emerge from more basic structures. If that is true, then the place where reality breaks down is not a location within space-time. It is the level at which space-time is created. Imagine standing on the surface of the ocean. Waves rise and fall around you. From your perspective, the waves appear fundamental, yet the waves emerge from deeper interactions between water molecules. The true foundation lies beneath the visible phenomenon. Likewise, space-time may resemble a wave emerging from deeper processes hidden beneath observation. At that deeper level, familiar distinctions may no longer apply. The difference between here and there may lose meaning. The distinction between before and after may lose meaning. The boundary between motion and stillness may lose meaning. Concepts that organize human experience may simply fail. This is not because reality becomes chaotic. It is because the categories we use to describe reality may no longer be appropriate. One of the most fascinating clues comes from attempts to understand black holes. Black holes push physics toward its limits because they combine enormous gravitational effects with extremely small scales. Near the center of a black hole, known equations predict singularities, regions where quantities become infinite and the mathematics breaks down. Most physicists do not believe actual infinities exist inside nature. Instead, singularities are often interpreted as signs that our theories have reached their limits. The equations are telling us something important. They are telling us that the framework is incomplete. The same message appears in other contexts as well. Quantum mechanics and general relativity each describe reality successfully within their own domains. Yet when pushed together under extreme conditions, inconsistencies emerge. This suggests that a deeper theory remains undiscovered, a theory capable of explaining what happens where our current descriptions fail. Many researchers believe that discovering this deeper theory may reveal what truly connects one moment to the next, because if continuity emerges from hidden structures, then the transition between moments may occur at exactly the level where space-time itself originates. The mystery becomes even more profound when we consider consciousness. Human awareness experiences reality through time. Memories point toward the past. Expectations point toward the future. Identity appears to persist through a sequence of moments. Yet if time itself is emergent, then consciousness may also be interacting with deeper processes than we currently understand. The experience of continuity may not simply reflect the structure of the universe. It may emerge from the interaction between mind and reality. Some researchers explore this possibility cautiously, while others remain skeptical. No consensus exists. Yet the question continues to attract attention because consciousness sits at the center of the mystery. The entire problem of connecting moments becomes meaningful only because conscious beings experience moments at all. Another clue comes from information. Throughout modern physics, information appears again and again as a fundamental concept. Black holes involve information. Quantum systems involve information. Entropy involves information. The deeper scientists investigate reality, the more they encounter informational structures underlying physical phenomena. Some theorists now suspect that information may be more fundamental than space and time themselves. If that is true, then the place where reality breaks down may actually be a place where reality reorganizes. A level where information exists before it becomes matter, before it becomes energy, before it becomes space-time, before it becomes the moments we experience as reality. This possibility changes the entire nature of the mystery. The question is no longer what exists between moments. The question becomes what creates moments in the first place. What process generates continuity? What process generates change? What process generates existence itself? We do not yet know. And that uncertainty is precisely what makes this boundary so important. It represents one of the few places where science openly acknowledges that the deepest answers remain hidden. The universe allows us to observe galaxies, particles, fields, and forces. It allows us to measure astonishing details about its behavior. Yet when we approach the level where time, motion, and reality emerge, the familiar framework begins to dissolve. We reach a place where explanations become tentative, a place where theories remain incomplete, a place where some of the most successful ideas in science encounter their limits. And standing at that boundary, one final question remains. If our concepts of time, motion, causality, and information all begin to break down at the deepest levels of existence, then perhaps the mystery is even larger than we imagined. Perhaps something really is missing from our picture of reality. And if something is missing, what exactly is the universe hiding from us? After everything we have explored, we arrive at the final question. It is not a question about a particle, a force, a galaxy, or a mathematical equation. It is a question about reality itself. If there truly is a missing link between one moment and the next, if transitions remain hidden, if the present cannot be clearly located, if information appears to move through processes we do not fully understand, and if the foundations of space and time begin to dissolve at the deepest levels of physics, then what exactly is absent from our picture of the universe? The question matters because history has shown that the greatest revolutions in science often begin with something missing. Astronomers carefully observed the motions of planets across the sky. The observations were accurate, yet something did not fit. The missing piece eventually transformed our understanding of the solar system. Later, scientists studying electricity and magnetism discovered patterns that seemed incomplete. Hidden connections eventually revealed entirely new aspects of nature. The same story repeated with atoms, relativity, quantum mechanics, and countless other discoveries. Again and again, reality appeared understandable until someone noticed a gap. That gap became a doorway leading toward a deeper layer of truth. Today, the mystery surrounding the connection between moments may represent another such doorway. What makes this mystery unusual is that the missing piece does not seem to reside somewhere far away. It is not hidden inside a distant galaxy. It is not buried beneath the surface of an alien world. It is present everywhere. Every event depends upon it. Every process relies upon it. Every thought you have ever experienced unfolds through it. Yet despite its constant presence, we still do not know exactly what it is. Consider what happens when you watch a clock. The hands move. Seconds pass. Time appears to flow. The experience feels straightforward because clocks provide a visual representation of change. But the clock does not explain what change is. It merely measures it. The movement of the hands tells us that one state has become another. It does not reveal what carried reality across the boundary separating them. This distinction is easy to overlook because human beings naturally focus on events rather than transitions. We notice outcomes, we notice movement, we notice transformation. We rarely pause to examine the hidden bridge connecting one state of existence to another. Yet that bridge may contain the deepest secret in the universe. Suppose for a moment that nothing is actually missing. Suppose the universe is complete exactly as it appears. Even in that case, we would still face a profound mystery. We would still need to explain how continuity arises. We would still need to understand why reality remains coherent across time. We would still need to account for the connection linking causes to effects, memories to experiences, and past states to future states. The problem does not disappear simply because the universe appears continuous. The problem is continuity itself. Why does existence remain connected? Why does reality not fragment into disconnected pieces? Why does the cosmos preserve order across billions of years of evolution? These questions remain unanswered. Now consider the opposite possibility. Suppose something truly is missing, not because nature is incomplete, but because our understanding is incomplete. This possibility becomes increasingly plausible as we examine the history of science. Every generation tends to assume that its fundamental concepts describe reality directly. Yet later discoveries often reveal that familiar ideas were only approximations. Ancient observers believed Earth occupied the center of the cosmos. Classical physicists believed space and time were absolute. Early quantum researchers struggled to imagine that particles could behave like waves. Each era eventually discovered that reality was stranger than expected. There is no reason to assume our current understanding represents the final chapter. Future discoveries may reveal hidden structures beneath space-time. They may reveal deeper principles governing information. They may reveal mechanisms connecting moments that are currently invisible. They may even reveal that the entire framework through which we think about time requires revision. One reason many physicists remain open to such possibilities is that modern theories continue to encounter unresolved questions. Quantum mechanics and general relativity remain extraordinarily successful, yet they do not fit together perfectly. The nature of consciousness remains mysterious. The origin of space-time remains uncertain. Dark matter and dark energy dominate the universe, yet their fundamental nature remains unknown. Every one of these mysteries suggests that important pieces of the puzzle remain hidden. Perhaps the connection between moments belongs to that category. Perhaps what we perceive as continuity emerges from processes operating beneath the level of ordinary observation. Perhaps reality contains structures that do not resemble anything familiar to human intuition. Imagine a two-dimensional being living on a flat surface. Such a being could understand length and width, but the concept of height would remain inaccessible. Even if height influenced every aspect of its world, the deeper dimension would remain difficult to imagine because the creature's experience would be limited by the framework through which it perceives reality. Human beings may face a similar limitation. Our thoughts are shaped by space, time, and causality because those are the conditions under which we experience existence. If the deeper foundations of reality operate according to principles beyond those categories, then understanding them may require entirely new conceptual tools. This possibility helps explain why the mystery persists despite extraordinary scientific progress. The challenge may not be that we lack data. The challenge may be that we are trying to interpret reality using concepts that emerge from the very system we are attempting to explain. Imagine trying to understand the rules of language while using only the sentences produced by that language. Imagine trying to understand the operating system of a computer while trapped inside one of its applications. The framework limits the investigation. Something similar may be happening with time. We attempt to explain continuity using temporal concepts. We attempt to explain moments using moments. We attempt to explain change using change. The deeper mechanism remains hidden because it may exist beneath the framework through which explanation normally operates. This realization leads to a fascinating possibility. Perhaps the universe is not hiding something in the ordinary sense. Perhaps the mystery persists because the hidden layer is so fundamental that it appears transparent. Think about the air around you. For most of human history, people rarely thought about it. Air was invisible. It surrounded everything. Its presence seemed so ordinary that it disappeared into the background of experience. The connection between moments may be similar. It may be everywhere. It may support every process in existence. It may be so fundamental that we continuously look through it rather than at it. If this is true, then the final mystery is not about discovering a missing object or a hidden force. It is about recognizing a hidden foundation, a principle woven into every event, a structure present in every transition, a process so universal that reality itself depends upon it. The remarkable thing is that we are not discussing an obscure phenomenon occurring only under exotic conditions. We are discussing something involved in every heartbeat, every memory, every photon crossing space, every star burning in the darkness, and every thought forming inside every conscious mind. The mystery touches everything, because everything depends upon the continuation of existence from one moment to the next. And despite all our knowledge, despite centuries of investigation, despite the extraordinary success of modern science, the bridge remains hidden. We know that moments appear connected. We know that reality continues. We know that the universe preserves coherence across unimaginable scales, but we still do not know exactly how. Perhaps future generations will solve the puzzle. Perhaps a deeper theory of reality will reveal what lies beneath space-time. Information, consciousness, and geometry will eventually be understood as aspects of a single underlying framework. The mystery will become even stranger as our understanding grows. For now, the question remains open. Every second that passes carries the universe forward. Every event emerges from a previous event. Every state becomes another state. The process never stops, yet the mechanism remains hidden behind the reality it creates. And that may be the most astonishing possibility of all. The greatest mystery in the universe may not be something distant, rare, or difficult to find. It may be the invisible connection that has accompanied every moment of your life. A connection so fundamental that you have experienced it continuously from the day you were born. And yet, even now, neither science nor philosophy can fully explain what it is. For all the knowledge humanity has gathered, this question remains unanswered. Every star that shines, every atom that moves, every thought that forms inside your mind appears to pass effortlessly from one moment into the next, yet the connection itself remains hidden. Physics can describe events with extraordinary precision, but the bridge between them still escapes observation. The universe continues its endless story, page after page, while keeping one of its most important transitions completely out of sight. Whatever links one instant to another may be so fundamental that we have been looking through it our entire lives without noticing. Until that mystery is solved, one possibility remains open. The universe is not only stranger than we imagine, it may be skipping something we have never learned how to see.